Good evening, everybody. Welcome to our last session. Welcome to B-Sides Las Vegas ground floor. This talk is going to be the last talk today in ground floor, and this talk is titled "eXes and OAuths They Haunt Me," and it's given by Darryl right here. A few quick announcements before we begin. We'd like to thank our sponsors, especially our diamond sponsors, Adobe and Aikido Security, and our gold sponsors, DropZone AI and Profit. It's their support, along with our other sponsors, donors, and volunteers that make this event possible. These talks are being streamed live, and as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to silent. If you have a question, you would be using the audience microphone that I'm holding so that YouTube can hear you, and I'd bring it along if you raise your hand. As a reminder, the B-Sides Las Vegas photo policy prohibits taking pictures. Yes, so please do not raise your cameras to take pictures. That's not allowed unless you have explicit permission later. These talks are all being recorded and will be available on YouTube in the future. And if you guys have already settled in, please feel free to move forward to let space for others who are coming in. With that, let's get started. Please welcome a speaker again.
How's it going, everybody? End of the day, Monday, right? We're all feeling energized, right? I was on a plane for about 15 hours yesterday, so I'm in the middle somewhere, but we're gonna get through this and we're gonna have a good time, right? This is going to be about cloud security, cloud authentication and authorization, some of the differences between OIDC and OAuth 2.0. So who am I? I'm just a guy. Currently, I'm a solutions architect for Netrix. Work a lot with Pingcastle, a lot of the old stealth bit tools and stuff like that. So everything from endpoint security to network security, but I mostly focus on identity. All right, so intros were quick. Just gonna talk a little bit about what OAuth is. We're gonna talk a little bit about OIDC, the differences between the two. There is a lot of confusion that I hear sometimes. Then we'll go over some of the vulnerabilities and common misconfigurations when you're developing your own custom web apps that need to interact with these authentication APIs. We'll wrap it up with a quick just token replay, attack demo, really just to show you the difference and the power of a bearer token versus other types of authentication in the cloud. Also, at any point during this talk, if you guys want to raise your hand or shout something out, please. I'm not a web developer. I'm not a developer of any sorts. I tinker a lot. I'm a guy that puts Band-Aids on grenades, right? And we hope for nuclear bombs. So I come in the clutch, I learn stuff real quick, and then we try to flip it and do something good with that. So I say all that simply because I'm learning too. I am by no means an expert in this. So let's have a good time and see where we get. All right, so what is OAuth in general? Not even just 2.0. What is OpenID Connect or OIDC? Why do they matter? Why am I even giving this talk today? So these two protocols are really, they're more than protocols. These two frameworks are really kind of the backbone of identity today when it comes to the cloud. A lot of people are using OAuth and OIDC and may not even know it, right? It's as simple as you've got Waze, and it's telling you where the traffic is. There's a cop around the corner or whatever, but you also want to listen to Spotify. So you're like, yeah, go ahead and give Waze permissions to talk to Spotify so I can listen to my next app, right? So these are kind of some of the things that we're talking about, right? Being able to authenticate or be authorized to use and access resources on behalf of just some random user across the internet, any internet. So essentially OAuth 2.0, it's a delegation protocol, right? And so it lets applications access resources on behalf of users. And it does that without having to handle passwords. And so the thing that's great about that means that the authorization server doesn't have to worry about passwords. The end user doesn't have to worry about passwords. Passwords aren't in your file systems. They're not in memory. They're not in your logs, et cetera, et cetera, et cetera, right? All the places we find passwords. So that kind of alleviates that piece to an extent. So there are still pieces that we have to worry about and we still have to secure, and we'll get into those a little bit. But these protocols are being used everywhere. They're used specifically for API calls, but we use them in mobile applications. We use them in SaaS all the time. And that's really what makes them a prime target, is that you can access them anywhere, anytime, all the time. And with cloud platforms like GCP, Azure, AWS, you have the ability to really quickly spin up these web applications that rely on these authentication and authorization frameworks, but they're not really doing any error checking or validation to make sure that your configuration is actually secure. It may work, but that doesn't mean that it works in a secure manner. Okay, so we're just going to start out with OAuth 2.0. So it was developed by IETF. It was finalized in 2012. So they actually have a whole RFC that's dedicated to them, 6749. That actually finalized in 2013 because they made an additional revision to it. But OAuth's been around for a long time. OAuth 1.0 was around for a very long time. By today's standards of like pen testing or red teaming or even cybersecurity, it was sloppy. It was effective, but it was sloppy. It's like throwing the noodle on the wall. My wife's Italian. Anyway, so if you're making spaghetti, you throw a noodle on the wall. If it sticks, like the pasta's ready, like that's what it was. Like maybe, maybe it worked. So there was a lot of holes in it. And so OAuth 2.0 came in order to try to bring more flexibility and to make the framework more extensible. OAuth 2.0 introduced 4 new grant types. It introduced authorization code, implicit authorization. Here are the fun ones: resource owner password credentials. And resource owners are you, the user, the person sitting on the keyboard, or client credentials. And the client credentials are the application that you built, the application that needs to interact with everything else in the wild. So you can still pass those credentials using the OAuth 2.0. Not needed, but you can. All right, so this is a pretty common looking page whenever you're interacting with OAuth 2.0. So this is IndieAuth, whatever IndieAuth is. That's cool, but it's gonna allow, so when I log into my Twitter account, it would allow me to, or rather it would allow IndieAuth to read tweets from my timeline and see who I follow. It even tells me what it can't do, and I will implicitly believe it, or I will read that long page that nobody reads, right? But that's really what OAuth looks like when you're the end user and you're interacting with it. It's really simple. You just say like, yes, I want it to be able to do A, B, and C. That's all it can do. And those permissions are just tied to that token. This concept is really important when it comes to OAuth 2.0 because a lot of people get one concept mixed up constantly between OAuth and OIDC. And it's that OAuth does not offer any kind of authentication. It does not know who the user is, does not know where the user came from, there's things that you can do to limit your audience and even limit where the issuer comes from, but there's no authentication that happens. It's simply a token that gets authorized to have access to some resource on behalf of the user. So if anybody has access to that token, they have the same access as that user does based on what it was given to that access token. Okay, so OAuth is relatively easy. There are a couple of terms that are weird and they seem not as intuitive as normal. Like when we talk about servers, there's a few different servers involved. When we talk about clients, when we're talking about cloud authentication, typically, not always, but typically when we talk about a client and server authentication communication, the client is actually the web application that is making that authentication or authorization request on behalf of you as the human or on behalf of some other entity that has actual access to some resource somewhere. In most scenarios, we refer to ourselves, right? We are the client. The machine we are is the client, but this is the cloud. We don't own those machines. The client can be a lot of different things. So the resource owner, that's actually who you are. As average Joe, you own whatever data that you have in the cloud, whatever frameworks, whatever services that you have access to, those are yours. And that's why you're the resource owner. So your web application, the whole point of it is to be able to mitigate that conversation securely and ensure that the web application only has access to the resources that the resource owner both has and has authorized. And those two things are not the same. Just because you have authorization to something does not mean that because you create a bearer token based on your identity, that that bearer token has to have, every privilege or permission that you have. You can actually make blank bearer tokens, which will give you back, you'll get a 200 OK, so you'll know that you're able to successfully authenticate, but you'll never be able to pull any resources back. So that's actually really useful for developers. All right, so this is a very, very, very basic authentication flow. This is more of an internal facing app or an application that's not going to be public facing at all. And we'll talk about a couple of reasons why. But just in general, that application on the left, that's your client application. Your user is the resource owner in the top right. And then your resource server in the bottom right. Those are kind of the big pieces here in this puzzle. So it's simply that you wanted to access something, so the application on your behalf goes ahead and prompts you as the user and says, all right, well, you can log in. You can use these different types of forms to log in order to grant this authorization, right? So let's say you use Google or you use Facebook or GitHub or any of these different providers. You go ahead and get that authorization grant. Once that authorization grant is received by your browser or your web app, you get a redirect URI. That redirect URI is going to send you to the authorization server. In a lot of cases, your authorization server and your resource servers are the same, especially if you're looking internally, but this authorization server is the IDP. So whether that IDP is Active Directory or Entra ID or Okta, doesn't matter. Google, doesn't matter. It will always perform the exact same functions. You'll get an access token, and then you can use that access token for subsequent API calls. Now, in a more secure world, so that last one was very straightforward. Doesn't matter what you came from, if I'm on a Linux machine, a Windows machine, a cell phone, whatever, right? I always hit that same backend. That backend interacts with the API the exact same way. There have been a lot of exploits around that because not all operating systems, not all devices, not all software interacts with these APIs the same way. And so if you just have a backend, or if you don't have a front end that's sitting there that knows how to interact with the back end based on how that client web application would best work, you're going to end up with not the best results. You might still pull in the data that you're looking for, but it might not be formatted correctly. It might not come in, human readable forms and that type of thing, right? So this screen, this is backend for front end. If there's developers that are here, I'm sure that you've heard of this. But backend for front end basically just opens up the front end so that instead of having a dedicated just one service that has to handle every single API call for every single type of client in every single situation, which is going to get wrong a lot, you actually have a dedicated backend for front end. So based on the type of client or the type of user or other types of criteria, you will have a dedicated backend for front end that will then interact with those APIs specifically. So this is brought up because this actually brings in a lot of optimization around just client-side programming and scalability, because you don't have to worry about for every single time that you want to add in another API service or something else like that, that you have to add it into this massive monolithic front end that has to handle all these different things. You can just spin up another backend for front end, and it just handles that API. Kind of similar to how MCP servers are working nowadays. If you guys are kind of in the MCP world, you've got this other server that does like the translation for you, and that's what these frameworks are doing. So this is a detailed just authorization flow. This is when you're using a backend for front end. It is very similar to especially from the user standpoint, it feels the exact same. You don't notice anything different. What happens is instead of having that authorization request go all the way to the authorization server, then back to you, and then you get the token all the way from the authorization server, then you send it to the application. The application itself has a backend that acts for you on your behalf as a front end, and it handles that token request. So it kicks off normal. You have an authorization request, no user interactions required. You get the redirect URI, you get the callback requests, You send it, the backend for front end then takes over, goes ahead and does the token request, gets the token, sends you everything you need, sets up the session for you, and then you're good to go. So the backend for front end does a lot of the heavy lifting so that a lot of the authentication pieces, or really the authorization pieces at the endpoint, right, using the token and actually being able to use that token to make a call is happening on your backend for front end instead of happening inside of the user's browser. And we will talk about why that's also a problem here shortly. Okay. All right, well, there was a video there. We had a minute and a half video that was going to show authentication. Don't know why that's not working there. Interesting. All right, well, we might wrap up a little bit earlier. That's fine. So when it's used, OAuth 2.0 is mostly used when it comes to delegating access for APIs and applications, right? It's made so that some other entity, typically non-human, can make requests and interact with some resource on your behalf. It enables login, and I lightly quote, I'm air quoting login just because of what login means to some people doesn't mean the same thing to identity folks, right? But it does enable login with Google, Facebook, GitHub, all kinds of different frameworks without you having to create an additional account. Say that again? No. I'm still on OAuth. Still on OAuth. So the question was, he's asking if I've changed and hopped over to OIDC. No, but we're about to get there next. So this is used, and that's why I air quoted when I said login, because the login is different to some people than others. So if you actually look at the RFC and the documentation, it references logging in, it references authentication, it references a lot of words that are not correct based on the protocol itself. So that's that. But speaking of OIDC, the prophet has spoken, and we're here now. OIDC is an identity layer that's actually built directly on top of OAuth 2.0. So you cannot run OIDC without OAuth. You have OAuth, and then you have additional pieces to it. Now, OAuth 2.0 was originally designed for authorization, granting third-party applications limited access to user resources. OIDC actually extends its support to authentication, meaning that with OIDC, you can actually verify and assert the identity of a user. This is really important because, again, like I said, OAuth alone doesn't tell the client who the user is at all. It just implicitly trusts that bearer token, and then it's just going to go ahead and give access to the resources that the bearer token has access to. OIDC fixes that by introducing a new type of token that's known as an ID token. This is typically a JSON web token or a JOT token. This JOT token contains the claims of that user. So it's got the username, it's got the email, the user ID, and anything else that the user wants to assert about themselves or claim about themselves. OIDC is actually a dominant standard right now, which is kind of interesting because when you look kind of statistically as to the progression of OAuth 2.0 versus like OIDC, OAuth 2.0, there were people that really were against it. They did not feel like it was secure enough. With this secondary layer of OIDC, I mean, it is hands down one of the most dominant, if not the most dominant, cloud authentication protocol that exists currently. So this is what it looks like, again, from the user standpoint. So Core Stack is just a learning platform that I use, right? In order to log in, you can create a new account, or you can log in with a local account with Core Stack, or you can sign in with Google, or you can sign in with GitHub. So the ability to be able to not even create a new account with a completely different system that you've never touched, and just click that, log in with Google, and then you get redirected, and now you have an account. You just use your Google account. This is OIDC, and we see this all the time. I can't remember the last time that I've actually logged into a web app on my phone, because most of the time it's just like, you want to just use that account? I'm like, yeah, Google it up, dog. Google it up, make it easy. Who wants to remember another password? All right, so how it works. Again, like I said, it does extend on the 2.0 authorization, the OAuth 2.0 authorization code flow. What it does do, it adds an additional token, and that token is going to be a JOT token. And the user identity is encoded in the ID token. Now, this is an interesting thing. So by the RFC standard, the user identity is encoded. However, JOT itself is not a standalone framework. It's an extension of two other frameworks. There's some really cool JSON stuff that's out there. Most of this is JSON web signing that we're talking about, and that typically uses encoding. But there's also JSON web encryption, and with JSON web encryption, the entire thing is encrypted. Like it's not just encoded. That's very, very hardcore stuff to break into. It's just not common. You just don't see it very often. Most of the time when we're talking about JOTs, we're just talking about JSON web signing with these additional security features. So it typically starts with just a user request. That user gets authenticated by some IDP, whether that's Google, Active Directory, Entra ID, anything else like that. That IDP will give the authentication code. This can come in a lot of different ways. It can come inside of the actual URI itself. It can come inside of a body. It can come inside of other forms of metadata, just depending on the IDP. A lot of times it just comes across inside of the actual return URL. So once you have that, you can use that return URL to get redirected back to typically the same IDP, but not always, but typically back to the same IDP. You've got your authorization code. That authorization code allows you to get a token. Now you have your bearer token, and you can use that token. Now, the difference is, in this scenario, instead of just getting the bearer token, you also get an ID token, and that's where that JWT or that JOT token comes into play. Again, so this is just that flow for OIDC, right? You've got the user request gets authenticated by IDP, which did not exist at all in any other flows that we've talked about before. So it actually knows who the user is before the user gets authorized to anything. You get the authorization code that gets sent back to the browser, and then the browser goes ahead and gets the token, and then can use that token for subsequent API calls. So not to spend too much time on JOT, because there's like a whole bunch on JOT. Like, if you guys like to break stuff, if there's red teamers out there, do it. Do your research. Do your research. It's awesome. That's just me. I love cryptography. But JOT token is basically made up of three parts, right? You've got a header, a payload, and a signature by RFC standard. You can implement JOT tokens and IDPs in a lot of different ways, and they don't necessarily have to follow these standards, but this is what the standard is via the RFC. What's interesting about it is, like I said, sometimes the body's encrypted, sometimes the body's encoded. All this typically is going to be pointed out inside of the header. The header is going to say, hey, this is going to be the encryption algorithm that we're using. This is going to be the length. This is what it's going to look like. The issue with JOT tokens and why they're such a prime target, and the reason why literally I'm having this talk today, is because JOT tokens are actually incredibly secure. They're awesome. They're amazing. The code that we write to verify JOT tokens, not so good, not so amazing, not so strong. And the problem is, unless, again, you have to know what you don't know, you have to have some really strong error validation to understand that, like, okay, well, this token went ahead and passed and I got back the resource that I needed, but did the verification actually go through? Did it actually look at the ID token, or did it just look at the bearer token and it got the resources? When it looked at the ID token, did it look at the entire ID token, or was that ID token expired last week and we don't validate for expiration dates? So JOT tokens are prime targets left and right all day. If there's any bug bounty hunters out there, you know what I'm talking about. All right, so when is it used? Always, all the time, everywhere, online. If you log into pretty much most modern platforms nowadays, modern applications tend to give you some sort of SSO type feel via OIDC, right? That's one of the main reasons why when you open up your phone, regardless of what type of phone that you have, you don't have to like log into your apps every single time that you log into your apps and things like that, right? We don't have to cache these passwords anymore. We have tokens to do these things for us. It enables more secure, I'm not going to say the most secure, but it enables more secure login across systems, especially across other things, other types of authentication and authorization, such as like basic or anonymous, or but those things do exist. They exist out there, and the pen testers and bug testers will let you know that it's really interesting when you start messing with claims inside of a JOT token, and you throw in guest, you throw in anonymous, you leave it blank, you throw in an actual null variable. It's kind of interesting to see what happens. So OIDC is widely used for federated identity and single sign-on. So again, when you use like Azure AD or Okta, something like that, you're pretty much guaranteed to be using OIDC underneath the hood. What makes it better, again, is it is just OAuth 2.0. It's just with this, you also have authentication. OAuth does not care at all about who is the person that's making this call. You can add in some flags, you can add in some parameters to narrow that down a bit, but there's no authentication saying that like, this came from a true proof of source, a source of truth rather. It's just out there. Whereas with OIDC, before you even progress to that stage of authorization, you've already been authenticated with that IDP. So we're going to swing back to OAuth 2.0 for a second, and we're going to talk about some of the vulnerabilities with OAuth 2.0. There are a few vulnerabilities that are targeted around OIDC specifically, but most of the attacks that really you see in the wild that work, that are successful, whether it's a bug bounty or it's some like 0-day or anything else like that, it's not OID specific. It's usually the OAuth underlying process of getting that bearer token. Because again, if you can get that bearer token and there's no other verification in the system, you're good. Or if the system doesn't know or it believes that you verified in some other way. And we'll talk about that here in a little bit. So one of the most common OAuth issues is a missing state parameter. And this parameter is kind of important because it links the authorization request to the actual response from the authorization server. So that's what actually prevents CSRF. Without that, anybody else can just hop in if they're able to listen in on your network, or for whatever reason they're able to grab this conversation, they can just hijack your session. There's nothing to stop them from hijacking that session at all. By having that state parameter in place, it highly mitigates, does not completely prevent, but it highly mitigates that from happening. The second issue, and this is the one that I see the most common when it comes to bug bounties, and in the past when I've done security assessments across Entra ID and just some of these, create your own application processes that some corporations have in place, is an overly permissive redirect URI, and then an overly permissive redirect URI validation. So the URI works, the redirect works, you go to the authorization server, it tells you, all right, awesome. So I've given you the callback, come back over to the server. And again, 90% of the time, if you're out in the wild, if it's not something custom you built, it's the same server. You went to Google, Google gave you the callback, you hit some other endpoint, back on Google, 99% of the time. But the issue is an attacker can actually put in their own redirect URI, right? If they're able to hijack the session, they can just say, hey, I'm gonna point it to my own server. My own server's got a nice IDP server that's running within the standards of RFC, so that authentication process is gonna go. It's gonna get a proper token, right? And if that user does actually have access and does have authorization to specific resources, more than likely you'll get access to some things. Depending on what type of environment that you have, in federated environments, like if we're talking about ADFS, that token a lot of times is not just tied to one service. It ties to like a slew of services. Like there's a whole bunch of different things you can do and move your way laterally. And then now you're laterally and you're in a different, you've got a different access token that you have. And from there, you can just continue to escalate and escalate and escalate, at least in the Windows world. Linux world, not so much, but in the world of Windows and ADFS, yeah, once you get in, you're good. Okay, so I'm not gonna spend too much time on this slide, but this is the same thing that we looked at earlier, right? It's still got the BFF in the middle. The only difference is now the first step, instead of it being the user saying that, hey, I wanna access some application that's out there, they've already been hacked, they've already been pwned. Some attacker has been able to inject some malicious JavaScript or whatever to run in their browser, as an example. It could be a fat application, it could be any application, they will all support this flow, but this is a good example, right? JavaScript. So JavaScript goes ahead and it starts off this authorization flow on your behalf as the user, right? Goes out, everything starts as normal, everything works the exact same. The difference is in this script, instead of this just being just a plain HTML request that just goes out normal, it's going to be called inside of an iframe. And you can make iframes incredibly tiny. You can make iframes invisible. You can make iframes in the background. So this entire call, this person's just like on Facebook or doing whatever, checking their mail, and they have no idea that all this code is just running in the background, right? So when that happens, you go ahead and you get the redirect URI. The attacker actually jumps in there and it'll stop that callback. And this is where the attacker sends that redirect back to their own server. So you see that right at step 7. And after step 7, the user is no longer in this authentication flow at all. At this point, this is an actual authenticated and authorized flow from that attacker. If you looked in your logs, everything looks good. If you looked everywhere else, everything looks good. For everybody except for whoever that user was, he's having a bad day probably. Of course, so that video doesn't work either. All right, cool. Don't worry, there's only 2 videos, so that was video 2. Let's, cool. All right, so additional OIDC vulnerabilities. One of the biggest ones is discovery document tampering. This is the way that you find, it's one of the ways that you can find some of these redirect URLs and some of these URIs. Many implementations of web applications actually trust discovery of documents and the issuer blindly. There's no verification of that. So like when you get a document and it says that it came from X, it came from Google, it came from B-Sides Las Vegas, there's nowhere really inside the application that's verifying that. So an attacker can actually just create fake tokens. Excuse me. So as long as they're following the RFC standards, that application is gonna go ahead and go through its normal flow. Now, one of the reasons why this is possible is because a lot of times when web developers are creating applications, they're either in a rush, they don't know, or they haven't fully switched from dev to prod, with that application, is they're not checking some of the parameters inside of the tokens itself. So the token has parameters such as the audience. Who is this token actually for, right? This token is for, DC05. But I'm presenting it over to file server 12, right? Why is it here? It should not be here. The issuer, right? The issuer should have come from, this is bad web implementation.net, and it didn't. It came from, this is really, really bad web implementation.org, right? So we're not looking for that. And there's also another state parameter known as a nonce. It's that one-time use. And a lot of times that's not even in place. And if it's in place, it's not being verified. Unless you're using a really kind of like major framework, I've never seen that just automatically added in. So if you're creating custom applications and stuff, the parameter for the nonce is not just going to be there on its own. And even if you create the nonce, the verification for that nonce is not going to be there on its own. So it'll pass and you'll think everything's good, but it's not actually verifying. And again, this is one of the biggest issues with OIDC is lack of verification, and there's no notification to you as the developer that yes, you succeeded to authenticate or to authorize, but you didn't succeed with your verification of the data to get to that authentication or authorization. Well, this one is not a video. This one's live. So hopefully demo gods are better than my YouTube gods, right? And I've just got, I've got an IDP and I've got a vulnerable web app that's there. Essentially, I'm just gonna log in. I'm gonna grab that bearer token. We'll curl it up, and we're gonna pull in some protected resources that I should not be able to get. But this bearer token, like I said, does come back across in the URI. And let me just do this. And we got a Docker container. Cool. Awesome. All right, so got the world's fanciest web application here. All right, look at that CSS, guys. Look at that CSS. Call me. All right, let's go ahead and log in. Stole this template as well. We'll just call it me. Doesn't matter. 1, 2, 3, 4. Then we'll go ahead and authorize. Cool. So I'm trying to pull in. There's a protected route called, it's slash protected. You can't get it to it unless you've been authenticated with the system. So I'm gonna go ahead and just grab this handy dandy information here. So this is the actual bearer token that's here. The bearer token does get returned back inside of the URI itself. So I just went ahead and made it easier for myself for when I'm doing presentations to just like, yeah, why don't you just present it to me so I can just copy and paste. So let's copy and paste. Hop over here, hop into Narnia. Yep, I'm one of those guys. And yeah, and just like that, completely different computer, completely different operating system, just use the same bearer token. I was able to get granted access to it. So this is just to show you that it's not about the security necessarily or the encryption or even the encoding when it comes to creating these JOT tokens or creating these like intense frameworks. Really, a lot of times where the flaws come into play, they come into play around the verification. So like you can have a token with the most security information in the world. If your application is not checking for that and then not responding appropriately based on what it finds, you're gonna find yourself in a situation every time. All right, so the reason this worked is there was no token binding, which means that I'm not using any layer of the session in order to tie into the actual token that I'm using as well. That's essentially a secondary signature. So if you change anything about the token or anything about the session, you know that something has been changed and it'll go ahead and die off. The second thing is my token does not have expiration dates, right? It's long-lived token. That's a very common thing that we see out there. So even if a token's been exploited a long time ago, it's the same thing like you see with service accounts. They need to have meaningful expiration dates. And the best thing that you can do, especially in a world of tokens, is that you want to have short-term lived tokens and just request and verify them on a more regular basis. You don't want to just have a long-living token and just hope it's still doing everything that you want it to do. The next thing is the no audience or the issuer validation on the resource server, right? So nothing to validate where it's supposed to be coming from and nothing to validate who this token's actually supposed to be served to. No token introspection or revocation support. This is kind of added on to more of like once you have a framework in place and you have the ability to verify, what do you do about it, right? Do you reject the token? Do you kick the token back? Do you alert the fire squad and they come down with the pitchforks or whatever? That's what you do there. And then like no logging or anomaly detection. So anomaly detection is a big one, especially in the cloud-based stuff. If you're building your own applications, it's a little bit harder. If you're using Azure, or if you're using AWS, it's already built in for a licensing fee. But, it is there, though. So the impact of this type of attack, I mean, it is a full account impersonation. Again, there is no verification, and there's not going to be any type of secondary, tertiary, or any following type of validation of that token. As long as that token is valid and it hasn't expired, it's going to stay valid. One of the cool things for red teamers and the things for blue teamers is the fact that whenever you issue these tokens, typically in almost all cases, they bypass all MFA and login defenses around MFA and that type of thing, right? Because they are meant to be used with non-human entities. So worse, again, when we're talking about federated environments, one token might give access to dozens of services. An attacker can pivot laterally, gather data, and even abuse APIs, escalate privileges, or destroy records. I don't know why I went up at the end of that like that was positive. It wasn't positive, but I felt like I was bringing it home. So detection and mitigation. Again, most of the things that I've talked about have not been any actual attacks. Nothing I've talked about has been red team centric. So I work in the world of identity. Most of the stuff that I deal with is identity. And besides like brute forcing and the stuff we've been doing for a very, very long time, most attacks on identity don't really come from any kind of like twisting or new Breaking Bad cool yellow jumpsuit type thing. They really just come from misconfigurations in the implementation of these frameworks. And then you have some guy who's sitting around or girl that takes the time to find that hole, find that spot that you didn't cover, and they're off to the races. So preventative controls are use short-lived tokens. Make sure that you validate the audience. Use a nonce. The nonce will stop almost all token replay attacks because it changes every single time. If you use a nonce, make sure that you verify that you use the nonce. And one last thing that I'm just gonna give like a tidbit, because I might have known somebody who did this, and that's why they created this talk, was in Node.js, there are two methods when it comes to verifying an OIDC token, that JOT token. There is a verify method, and there is a decode method. If you don't read all the way down to the bottom of the page, you only got to the decode message and not to that verify message, and they do similar, but not the same things. The decode method will actually say like, hey, yeah, this is a valid token. You can use that token. It's good, but it doesn't verify it. It doesn't say that the information that I got from it that is in the right format is actually the information that should be in that token. So it's little things like that, really on the developer side of trying to figure out and make sure you learn the things that you don't know. So for me, when I had to create an app in the beginning of the year, I did not know a lot about a lot that I did not know, and I went down a lot of rabbit holes and broke a lot of things and pissed off a lot of people, but we got there. There are a lot of detection measures. There's a lot of ITDR solutions around this. There's a lot of monitoring, especially with AI nowadays. Everybody and their mother, any of the big cloud platforms are going to offer some kind of heuristic behavioral analysis implementation. Again, it typically costs money, but for most organizations, that's not something you can implement on your own. You do typically have to outsource that to a third party. So OAuth, OIDC, powerful but complex, very small configs, missing one word, missing one parameter, not verifying one thing. It can negate every single thing else. So little mistakes can cause large issues. And really, you just have to continuously test and monitor your environment to ensure that your applications are doing exactly what they're supposed to be doing, and only the identities that you want have access to the data that they're supposed to have access to. And that's it. I think I made it with a minute and a half to spare.
Yeah, so your certificates, would you say maybe like a typical workday plus like a couple hours for your hardcore devs?
You're saying as far as securing how much time they're
When does your cert expire?
Oh, so that depends. It depends on the resource, right? It depends on the access, because you created that authorization for a reason.
Like what I'm thinking of is, like your login cert, but there might be other kinds of things.
Right. So because you have to have some kind of human interaction, you have to have some kind of human interaction in order to renew that token. It's how often does that human need to interact, right? So if you have something that runs every single night, maybe the human, if it's just updating something, right, like it's WSUS or something like that, maybe you just need to interact with that once a week. If it is financial software, right, and it's updating, transactions for the entire day, yeah, you might want to look at that every single morning and make sure that you have a refresh token and that you're good to go, so. But that is operational, not technological.
In the beginning of the talk, you drew an interesting parallel between this and the MCP servers. I was just wondering if you've seen any similar attack vectors in the MCP space, or if anything is like parallel to that world.
Oh, as far as attacks?
Yeah.
And the MCP, no, not yet. But they're coming, because there's so many MCP servers that are openly available, like on GitHub, and script kiddies don't verify their text, and you're trusting some third party to make every single API call on your behalf. So yeah, you should probably read through that code before you hit go and do this thing using my credentials.
So can we expect like similar kind of identity problems with that space as well, probably?
As far as MCPs specifically? Yeah. Well, I think that's really where it's at, because an MCP server is just a translator, right? That's all it is. It's taking out the time for you to modify your code every single time that an API endpoint changes or that you want to interact with something else, and it can just do that for you. You creating an MCP server, I don't really see any inherent issues with that. Depends on, of course, like how you're interacting with it, but I don't see any inherent issues with that directly. It's more of when you trust that code from somewhere else, because you're going to give it your authentication, you're going to give it authorization, it's going to interact with APIs that you think it's interacting with, but if you haven't done any kind of SaaS testing at minimum against that code, I wouldn't run it.
Okay, thank you.
I'm gonna ask something that's more specific. So, I mean, if you can't answer this question, that's okay because it's very specific. So the CSRF attack, the flow that you demonstrate earlier. So that one. So, is that the condition for that to work? Is because that flow uses the set cookies. So if, for example, if I don't persist the token on the disk,
Yeah.
would that prevent this kind of issue happening?
So I don't know the full answer to that. I don't want to say the answer is yes, but I will say this, that regardless of if the cookie is present or not present, it can still work. It does depend on the type of cookie that you're using, because you can execute this code regardless of if the session is stateful or stateless.
Yeah, that's interesting.
Are you familiar with the passkeys at all?
No.
Because some of the issues you've talked about, like lack of revocation, lack of logging,
Yes.
lack of transparency, I believe issues affects passkeys as well. It's hard to, when they go bad, you don't know they go bad. If
Right.
they're stolen, you don't know if they're stolen. And they are a pretty cool thing, but there's just little flaws in the implementation that sound like this.
Yep. Yeah, and it's because you're using some other method in order to represent your credential set. You know, we see the same thing with Windows Hello is pretty solid, but a few years back and stuff, you know, when you're using cat cards and things like that, like it's interesting, right? Because it's just tying your password or your identity, not really your password, but your identity to like some PIN that's on your system. So if your system gets compromised, all you have to do is set a new PIN. You don't have to change your password. You don't have to worry about that.
In your example earlier, you had the token coming back from your IDP in the URI. And then in your list of misconfigurations, I saw both URI containing the token and Pixie. Isn't Pixie supposed to solve that, or am I completely off the reservation there?
Yeah. Okay, hold on. Let me go back a couple slides. It's a good question. It's a good question. I don't want to say it wrong, and I got notes for this. I was waiting for this question. So Pixie, proof key for code exchange. We're talking about, right? Yeah. So it is an extension of OAuth. In this particular case, the access token is accessible in the browser because it was stored like in memory or in DevTools, and that's what it's supposed to simulate. It's supposed to simulate non-secure storage, right? Because like I found them, well, not me personally, but they've been found even in logs, right? Like its credentials, right? And that's what that's supposed to show.
Okay, so if my IDP really wants to give me the token in the URI, that's not fundamentally flawed. I just need to be very careful with how I handle it.
Exactly, and that's really the takeaway for this entire talk, right? Is like the framework itself actually works really, really well. You just have to be careful in the way that you implement it, because there's a lot of pieces to it, and like you miss one thing, you might get a valid token, but it's not being verified, right? So it's valid for some, but not for the rest, right?
Thank you, Darryl.
All right.
Thank you guys for coming today. Hope to see you guys tomorrow. Have a great rest of your evening.